We're going to take a look now at tests involving paired differences. So a couple of definitions first up here. Two samples are independent if the observations in one are not in any way related to observations in the other. And then we'll say two samples are dependent if the sampling is done in pairs or if the samples are in some way related. So to make a test about the difference of two means from dependent samples, we're going to use what's called the paired sample t-test. Now, here's the test statistic that we're going to use. This is going to be our measuring device to measure the discrepancy between the two means. It's going to be a t-statistic. It's going to go like this: d bar minus mu sub d divided by s sub d over square root of n. Now, it may look a little odd because we haven't seen these letters before, but let's talk about it and you'll see that it's something pretty familiar. The t-statistic we used before was this: t equals x bar minus mu divided by s over square root of n. And just look what each one of these things are here. All right, so x bar is the mean minus the assumed mean, right? The observed mean minus the assumed mean. Now look over here. D bar, that's the mean of the differences, all right? So we have paired samples, so we just take the differences of the pairs, find the mean of those differences, subtract what? The mean of the differences, all right? So it's the observed differences minus the mean of those differences, divided by standard deviation over square root of n. This is just the standard deviation of the differences divided by the square root of n. Now it is a t-distribution, so we have degrees of freedom. And in this case, degrees of freedom is going to be n minus 1, sample size minus 1. And d bar, all right, the d bar right here, that's the average of the d's. And how do you find the average of the differences? Well, you add up all the differences. You add up the differences and you divide by the number that you have. And then the standard deviation of the differences, all right, standard deviation, so it's going to be a square root, and here's what we're going to have, numerator, denominator. So here's how you get the numerator. It's the sum of the d minus d bar, all right, so it's the difference minus the average difference, okay, and then we'll square that. And we'll divide the whole thing by n minus 1, square root of all that. And now we've got everything that we need for our test statistic, right? We've got d bar right here, mu sub d, right? That's going to be what we're claiming, our assumed value. Degrees of freedom, we've got the standard deviation right here, and square root of n, that's just the square root of our sample size. Now, this is a lot of computations, especially in here. So I'm going to skip all the details, and we're going to do it directly on the calculator. Let's look at an example. So suppose a company wishes to study the effectiveness of an extended break on the productivity of its workers. So it selects 6 workers and measures their productivity on a day without an extended break, and then on another day with an extended break. And here's the data, right? You've got 6 workers without the extended break, maybe whatever these are, like, okay, we put together this many pieces, and with an extended break, put together this many pieces. Here's the question. Do these results indicate that an extended break increases productivity? Now, we're going to see how to do this directly on the calculator, but before we get into that, just take a look at something so we have an idea of what's going on here. Take a look at the differences. Say, all right, how about differences with a break minus without a break? Let's just make another column here. So what do we get? The first one is going to be what? Okay, now I'm doing with a break and then without a break. So if I take that difference, it'll be 28 minus 23. So I'll write it so you can see where I'm going. 28 minus 23. All right, that's a 5. And then this would be, all right, with minus without. What do we get here? 38 minus 35. Okay, so we get a 3. Okay, I'll just write these down. So then it's what? 29 minus 29, that's a 0. 33, 37. Okay, so 37 minus 33, all right, that's a 4. And then 42, right here, 42 minus 43, well, that's a negative 1. And then 30 minus 32, okay, from here, 30 minus 32, that is a negative 2, all right? And if we add these up, here's what I'm going to add up. 5 and 3 is 8. Here's 12, 11, 9. So if I add up the differences, I get 9. Now, what I'm going to do is I'm going to take the averages. What is D bar? All right, D bar would be the 9 divided by, well, we had 6 right here. So the average is going to be, what, 1.5. So it's actually plus, right, plus 1.5. So there is some indication that an extended break may increase productivity. Now, so we know what the calculator is doing for us. Here's these formulas. Look at all the work that's in here. I got to take all the differences. Now, we did that here just for 6, and that took us some time. So I got to take all those differences. I got to find the average. Then I have to make all these subtractions. That's usually going to be a 0. But then I got to do this, and look at all the work involved in there. All right, so let's have the calculator do all this work for us. So I'm going to have, as you can see here, I've got 2 lists. I've got a list 1 and a list 2. So I'm going to go into my calculator. I'm going to put this data into list 1 and list 2. So go to Stat, press the Stat key, and then number 1, Edit. So go to Edit, Stat, Edit. Now you're going to see lists. You're going to see L1, L2, and L3. Actually, there are 6 of them. You want to be sure your lists are cleared. So use your cursor, get into list 1, and cursor all the way to the top. So your cursor is on that one. And then press the clear key, and then press enter. All right, clear and enter. All right, that'll clear all that list. Then arrow over to L2, all right, L2, and then press clear, enter. Then cursor over to L3. I'll do it too, and press clear and enter. So now list 1, list 2, and list 3 are all clear of data. Now get your cursor back to list 1, and we're going to start putting our data into these lists. So it probably doesn't matter which way you go, but I'm going to put the with the extended break into list 1. So I'm going to put these numbers into my L1. 28, 38, 29, 37, 42, and 30, right? So you type in a number like 28, press enter. Takes you down to the next line. Then cursor over to L2 and put those numbers in. 23, 35, 29, 33, 43, and 32. Now cursor over to L3, all right? So you get your cursor in L3, now go up. Get it actually up here on L3. So you use the right arrow and then the up arrow. So get your cursor right on L3. In L3, you're going to put L1 minus L2. Now, where do you get L1? All right, so L1, if you look at your number key, right, look at the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, down at the bottom there. All right, so right above the 1 in blue is an L1. Right above the 2 is an L2. All right, but they're in blue, so you need a second. So what you're going to have to do is press second, and then the numerical key 1. All right, and so when you do that, L1 pops into place. Now put the minus sign, so press minus. So just the regular old minus sign, and then second, L2. Press enter, and what happens is it fills, the calculator actually does all those computations and fills that area with those numbers. And those just happen to be the numbers that we did before we started putting things into lists. Now we're ready to run this test. So back to Stat, press the Stat key, select item number 4. Now item number 4 says two-samp t-test. So press enter, select item 4, press enter. And then it's asking for some information. This time we're putting in data, right? So select data. We've got data in here. So select data, get your cursor on data and press enter. Now here's what it's asking. What's the data from list 1? All right, so we actually put our data into list 1, right? So you need to get that L1. And where do you get L1? That's on the number 1 key. So you press second and the numerical key 1. And what comes up then is L1. Press enter. Cursor goes down to list 2. And list 2, all right, that's going to be exactly our list 2. So second, L2. Right, actually, I could write that right in here, right? So you write second, and then you press the number 2, and you get L2. Now, the frequency in each case is 1. That means each number in those lists is going to appear 1 time. Now, what do we do here? mu1, how is it going to compare to mu2? Well, we are doing like a before and after type test, right? We're pairing the data, and we want to know if an extended break increases productivity. So we took extended break minus regular break, and hopefully if they're going to extend, we should see positive results. So we're thinking that mu1 should be greater than mu2, right? Our numbers, our mean from list 1 should be greater than the means in list 2. So we're going to select that one. Next thing that comes up is pooled. Right, now we are pooling the data. We're going to take all of these as one standard deviation. So get that on yes. We're going to pool our data. And now you calculate. And when you calculate, a bunch of numbers come up. Here's the one we're concerned with, right? We want the p-value. All right, so we're getting a p-value of 0.3422. So what do we do with that? Well, let's set up our test, and then we'll draw a conclusion. So as I set up this test, I'm going to write it like this. H naught states that mu sub d, now I'm going to leave that blank for a minute. H sub a states that, all right, mu sub d. Now what do I want here? I want these means to be greater than 0, right? That's what we just wrote. We wrote L1 greater than L2. So we want to know, do we get an improvement in our mean? So is the after better than the before? So that's going to be a greater than. So we always get this one first. Now just what is going to be the opposite here? So what's the opposite of greater than? Well, that's going to be less than or equal to 0. Essentially 0. Mu sub d is 0. No difference in the means, as opposed to, yeah, there's a positive difference in the means. Now, we need an alpha value. So why don't we choose, now remember, this is up to us. What if we just chose alpha equals 0.05? So now you compare P to alpha. Okay, I'll write a little table. P, alpha. All right, P is 0.3422. Alpha is 0.05. Clearly, P is greater than alpha. Now we've got to remember what to do. Does that say reject H naught or fail to reject H naught? I remember it this way. Greater than means high. I'm dealing with the p-value, so it's high probability. And if it's a high probability, it's likely. So I'm likely to see this. So I will fail to reject, right? If it's likely, I'm not going to reject. Fail to reject H naught. So now let's write a conclusion. Here's our question, way back here. Do these results indicate that an extended break increases productivity? Our results show that there's no evidence for that, so I'm going to say this 2 ways. Here's one way. I could say at alpha equals 0.05, this sample indicates that, and then I'm just going to write what's in the sentence here, in the wording of the problem. This sample indicates that an extended break does not increase productivity. That's one way to say it. Another way might be at alpha equals 0.05, there is not enough evidence to support the claim that an extended break increases productivity.